Hello guys, I'm Muntasir from Onushondhani lab. Today we will learn how to detect if a person is wearing a mask or not. We will train our own dataset for this. Before start training, we need to collect dataset and level them. You can see I have already collected almost 492 photos. There are many leveling tools available in the internet. I will use Level IMG version 1.8.0. I will provide you the link in the description box, of course. Download it and unzip it. After unzipping, you will find two folders. Click on the Level IMG exe file. Then you will find the interface like this. First of all, click on Open Directory. Select your dataset directory. Dataset. Select. After that, select your save directory. Desktop dataset. Select folder. Then you can see two options here, Pascal VOC and YOLO. As we are using Tensorflow, we will keep it as Pascal VOC. Then click on Create Rect Box and create a rectangular shape on the face, including the mask, and tag it with mask. Save it. After that, click Next. As we can see, this person is not wearing masks. We will click on Create Rect Box. Again, create a shape and level it without mask. And save it. We need to level each and every image individually. After that, you need to divide your dataset into two different folders, Train and Test. In the train part, there will be 80% of your dataset, and in the test part, there will be rest 20% of your dataset. Now you are done with your leveling. After that, we will download some file from GitHub. I will provide you the link in the description box. First of all, download this one, TensorFlow models, then TensorFlow Object Detection API. After that, from TensorFlow Detection Model Zoo, we will use Faster RCN and Inception version 2. This one. Click on this and it will automatically start downloading. Now, I have already downloaded them. Click on Models Master, extract here. After that, click on Models Master and rename it with Models. Extract the first RCNN and extract TensorFlow Object Detection Model. Copy the first RCNN Inception version 2 and paste it in the Models Research Object Detection folder. Go to your unzipped TensorFlow Detection API. Select all, copy, and again paste them in the Models Research Object Detection folder. Replace the file in the destination. Now, go to your local disk C open a new folder named Tensorflow 1. Copy your models folder and paste it in the Tensorflow 1. And now we can start our training. To start our training, we need to download and install Anaconda. After that, we will find Anaconda prompt here and we will run Anaconda prompt as administrator. Now, for the command, we will take help from Edge Electronics GitHub page. First of all, copy this one and paste it here. Press Y and enter. After that, for activate your environment, copy this one and paste it here. Upgrade your pip. Now install TensorFlow GPU in your environment. Now you need to install all these packages one by one. Copy from here and paste it. I think I have done something wrong. Okay. I have installed each and every packages from this. Then we will copy this command. Sorry. We will copy this command and paste it here. After that, we will change your directory. And copy this one. After that, we will copy these two comments and paste it here, one by one. Now you need to change the directory. Copy this and paste it here and write cd before that. Press enter. After that, you need to generate training data, but before generate training data, you need to change something from generate tf records file. Go to your local disk C, TensorFlow 1, models, research, object detection, and then generate TF records. Open this py file with notepad and change row level and save it. So that you need to go to training folder and level map pb text. Open this also with notepad and change item id1 equal to name with marks, id2 without marks, and save it. Now you can start your generating training data. Copy this python xml to csv.py and paste it here. Now you can find test level and train level for your test and train folder. You can see test level CSV and train level CSV. Now go to your Google Drive, open a folder named Tensorflow, copy your models from local disk C and paste it here. After that, go to Models, Research, Object Detection, and then Training. Select this first RCN and Inception folder. Open this with text editor like me, then change some directory from this folder. As we are using Google Drive, we don't need to mention local disk C TensorFlow. Follow me and cut these things. Recheck it again and save it. After that, we can start our trading. Go to TensorFlow 1 folder and open a new Google Colab folder and rename it with anything you want. Go to runtime and then change runtime type to GPU and save it. Then we will use this link for our further information. First of all, copy TensorFlow version 1.x and paste it here and run this cell. After that, you need to import TensorFlow and paste it here. After that, you need to mount Google Drive with Google Colab. This will create a link. Click on the link. This thing will generate an authorization code. Copy the authorization code and paste it here. Press enter. This will mount Google Drive with your Google Colab. Then change the directory. As we are not using our desktop, we need to change the desktop to TensorFlow. We don't need to use step 7 because we are already make our models folder in our desktop. Now copy this and paste it here. Run this cell. Next, you need to copy this Don't forget to change desktop to TensorFlow and run this cell. After that, we need to set our environment. Copy this command, paste it here. And there are two directories you can see. The first directory you need to change desktop to TensorFlow, as well as in the second directory, and run the cell. Then copy these two code and paste it here. It will take some time. We are almost done. Now we will check how much time we have left for our Colab session. We have still 11 hours. After that, copy the code to check if we have done everything for our training. Again, change desktop with TensorFlow. Oh, there is an error. We need to fix it. Pip install pf_slim. Run this code. Now run the previous code again. Check. Now we can see we do not have any error. We can start our training right now. Now we will create our train.record and test.record folder. For this, we need to go to object detection folder. Just copy from here and paste it here. For creating test and train record folder, we will go to Edge Electronics GitHub page and copy these two commands. We will paste it here. We will put exclamatory sign before both of line and replace backward slash with forward slash. And run the code. You can see we have successfully created our test.record and train.record file. Now we will start our training. For start training, you need to go to Edge Electronics GitHub page and copy the code from step 6, paste it here. Don't forget to put an exclamatory sign before the code and run it. We have get another error. For solve this, you need to put legacy before the train and backward slash, run the code again. Now it will start training. It will most probably take 3 to 4 hours, and then your loss will be 0.05 or something like that. You can see our training have already started. I have trained my dataset for 6 hours almost. Now my loss is 0.02. Now we can stop our training. Then we will create our TF records file. For that, go to your Edge Electronics GitHub page and copy the step 7 and paste it here. You can see there is a xxxx model.ckpt xxxx. We need to replace it with something. For that, go to your drive, models, research, then object detection, and finally training. Copy the model.ckpt and you need to copy the name 164612 and paste the number here and run the code. Sorry, you need to put an exclamatory sign before this. And now we can check if our model is working or not. For that, from object detection folder, you will find object detection image.py. Copy the code from here, and after some modification, like you need to change your image name, and you need to add from Google Colab.patches import cv to imshow, and from you need to add something here also and run the code. See if our model is working or not. Yeah, it's working. It can detect I am wearing a mask. Let's see in another image. It can also detect me without marks. We are done. Thank you for watching my video.